Hi, this is Fico, and welcome to another episode of our series of building a regulated asset with smart contracts. In this episode, we're going to cover the code base for the first version of our use case. This is the code base that we'll be using to iterate upon and building new features as we move forward with the series. So let's get into it. Alright, let's get into it. So this is our main folder where our project is located, and here you can see that we have two contracts to manage this use case. We have both the regulated asset, which is the asset itself, and we have the asset controller, which is a contract that contains all of the rules that needs to be enforced upon our contract. So I'll start by jumping into the regulated asset and giving you a tour about what was changed from a default implementation. Here we are borrowing from Abundance's implementation of a contract. It's pretty standard. It implements the standard token interface, which is the interface that we expect as a standard in the ecosystem. And here we just have one very small adjustment done to the interface. So we have the same functions that we normally use for an asset. We have the transfer, approve, set admin, and so on. The small tweak we did was to add an extra parameter for the initialize function. So the initialize function is like the constructor of the contract. It gets executed once we want to initialize an instance of our contract, and we pass on the parameters of how this contract should operate. In case of a contract that represents an asset, we normally pass on the admin, the decimal places, the name of the asset, the symbol, and so on. And here we are also passing an extra address. And this is the address of the asset controller contract. So we're telling our asset, this is the asset controller that is going to enforce the rules for you. So if we jump into the initialize function, we'll see that it's a pretty standard one. We're verifying if it wasn't already initialized or if we should move forward with it. And what we do here as an extra step is to, right after we write the administrator, we store the address of the administrator. We also store the address of the asset controller. And this is very standard. If I access it here, you see that I have these two functions to write and read the asset controller from the blockchain. And I'm storing that so that every time that someone invokes the token contract, we retrieve this value, we see who is the asset controller, and then I invoke the asset controller before executing any functionality in the asset itself. So here we can see that we have a data key for asset controller, and if I go to my storage types, I can see in the data key enum we have an extra item, which is the asset controller. This is the identifier that we'll use to store this information for this contract. So whenever we write the asset controller address, we write to this data key, and once we want to retrieve, we provide this key so we know that we're getting the address of the asset controller. So that's what we're doing with these functions here. I'm writing with this data key the address of the contract. And one important step here, you may notice that we're using the instance storage. This is one of the storage types you have with Soroban, and this one is specifically important for this kind of data, because this means that for the lifetime of a contract instance, all of the data that is stored in the instance storage will be maintained and accessible. So in this case, as long as I have an instance of my contract going on, I also want to have the asset controller being managed and being accessible. This is especially good for data that needs to live alongside the instance. So for example, the admin address or the token metadata, like the name of the token, the decimals, the symbol. This is the information that, as long as I have an instance running off my contract, I want this information to be accessible and stored properly. So let's move forward. Once I initialize this contract and I write the asset controller, now my regulated asset knows what is the asset controller that they are going to use to enforce the rules. And if I run down below and check the other functions, these are pretty standard implementations until we get to the transfer one. Here's where we did some adjustments. So we chose specifically the transfer function to start, as it is the main function used by anyone that invokes this contract, because they use the transfer anytime an account wants to send assets to a different account. And that's where we want to start plugging in our rules. We can later on expand to other functions to add rules that are specific to the minting process or the burning process, in case we want to control how the supply is increased or decreased according to some regulation. But right now we just want to enforce some rules upon the accounts transacting. So in here we start the transfer pretty standardly, just by verifying if it was authorized by whoever is calling it. So the sender has to authorize this invocation. Then we check for non-negative amounts, just to make sure we're not sending any invalid amount of tokens. And here you can see this is something you get used to as you see some contracts. Here we're just bumping the instance storage to extend its lifetime. We'll get to that in the future, but right now it's just important to note that this is the kind of action that ensure your data is up to date and accessible from the blockchain. All right, moving forward, here we start to see some changes. So after I did all the initial validation for my transfer, before I carry on any sort of changes in the values, and before I start sending the tokens around, I first invoke my asset controller. And to do that, we read the asset controller address from the blockchain and we store in this variable. Then we use this variable to instantiate a client of this asset controller. And with this client, we can start interacting with the asset controller directly here from the regulated asset. This is one way of making so that contract A can invoke a function from contract B. So what we're doing here is that we're using this asset controller client to invoke the review transfer function. We'll get to that in a minute. The review transfer is a function we created in the asset controller to enforce the rules that we want to enforce upon the transfer function of the asset. So it receives the same arguments from, to, and amount, which refer to the sender, the receiver, and the amount being transacted. The same parameters we have in the transfer. So what it does is, at this point, the asset controller will be invoked for this function. They will verify this information. They will enforce the rules they want to enforce. And in case this is not a valid transaction, they will simply stop the transaction. The transaction will fail right away and it won't be carried. Now, if they identify that everything is okay according to the rules, then it will give a thumbs up and the transaction will move forward to execute the normal actions, which would be to update the balances and emit an event to tell the off-chain applications that the transfer just happened. So from the perspective of the regulated asset, that's it for this first version. We're starting very simple, and then we'll iterate over that with other functionalities that we'll be adding in the future. It's important to note here that since we are only targeting the transfer function right now, this does not affect other functions that could also move balances around. So one example of that would be the mint function. The mint function that we have here in the contract on top, let me just get to it. The mint function is used by the admin of the asset, and it's used to generate new units, new supply. And instead of moving from one account to the other, it creates new units, it's minting new supply straight into a target account. So in this first version, we decided to not enforce any rules when an admin is doing an action like this, but in the future we can expand to bring specific rules for this kind of functions in case we want to audit how the supply is managed and how much supply can be created or burned at any given time, or even to create safety measures in case an admin account's compromised and we want to make sure that no hackers are just minting new units and flooding the market and crashing and collapsing the asset or something like that. So, all right, from the regulated asset perspective, that was it. Very simple. Now let's dive into the asset controller and understand what it does once we are reviewing a transfer. All right, from the asset controller perspective, let me jump right into the contract and give you an overview of what we have here. The main structure of the asset controller is very simple. We also have an initialize function, which initializes the contract with the parameters that define the rules for this asset. Then below we have the review transfer, which is the function that is going to be invoked when we want to review a transfer coming from that asset. And then we have a bunch of get functions to get the contract parameters in case some application off-chain wants to verify what are the parameters that this contract is enforcing. And we have some other get functions to retrieve information from the account perspective. So in case I want to understand how long an account has to be in probation still, if their period has ended or not, if an account has some quota allocated or not, and in case they have quota allocated, for how long this quota is still going to be allocated before they can do further transactions. All right, FIFO, but what is the quota? What are you talking about? If you recall our other video about the use case, we have some parameters that we want to enforce in this first version. So let me get back to the initialize here. When we initialize the asset controller, we are passing a bunch of arguments that we want to use to this initialization. The first one is the admin address. So this is pretty standard. Right now we're not doing anything fancy with it, but in the future we want to let this admin manage the asset controller and maybe do some dynamic changes to it, maybe changing the rules or changing the parameters, the periods in which people have to be in probation, or even to pass on the assigned assets to a different one, and so on. The second parameter that we get here is the asset address. So in the same way the asset knows the asset controller, we want the asset controller to know the asset that is invoking it. That's an arbitrary decision here because we want to make sure that whenever we are invoking this contract to review a transaction, we just want to do that for the assets that we collaborate with. We don't want to be invoked by other assets or by accounts that are invoking us directly. This can be changed to bring different rules to the ecosystem, but right now we just want to make sure that we are only invoked by the asset contract that we know. Then we have the parameters that define the rules. The first one here is the probation period, so it's how long an account has to be in probation once they start interacting with this asset. So in this case, the first time I interact with this asset, I start my probation period and I will be in probation through the whole time until I reach this period, this duration. And once I finish the probation, then I am free to interact with the asset with no rules being applied. Then we have the quota time limit as one of the limits that we are applying during the user probation, during the account probation. We want to ensure that they do not transact more than a specified quota for a given time. And this given time is the quota time limit. So let's say that I want to limit how much an account can transact every 24 hours. So I would set the quota time limit as 24 hours. And this would make sure that each transaction allocates the quota for 24 hours before it releases the quota again and you can transact some more. And then below we have the quota limits. So for inflow limit, we have how much an account can receive during this period, and outflow limit refers to how much an account can send during this limit. So you can have different values for how much an account can receive or an account can send during this time limit. Perfect. So how do we initialize the contract? It's very standard. We just do a simple verification. If we have an administrator registered, this means this contract has been initialized already because the administrator is registered during the initialization. And in case we don't, this means this is the first time the contract is being initialized. So we just move forward and save all the data. So what we do here is pretty much to store the data on chain so that whenever we have to execute or perform a check, we just retrieve it from the blockchain and see what are the limits and the periods that we have set for this asset. And if we get into these ones, you'll see that we use pretty standard read and write functions just to store in the blockchain and retrieve from the blockchain. And here we also using the instance storage because we want this information to be accessible as long as we have an instance of our project going on. And to identify this data, if we move on to our storage types file, we can see we have an enum for the data keys that we use to identify this data, and we have basically one for each one of these main parameters of the contract. So we have one for the admin, we have one for the asset, which is the address of the asset that we interact with, we have one for the outflow limit, one for the inflow limit, and so on. And we get to the other ones in a moment. All right, so this is what we do during the initialization. So let me just go ahead now and talk about the review transfer. So let me collapse this here. Let me collapse this here and get to the review transfer. The review transfer is invoked anytime a transfer is done in the asset. So here is how we start enforcing some rules and updating some controllers that we have in this contract. To start off, the first block is to verify if this invocation was correct. So we verify if the contract is initialized. We don't want to be reviewing anything before the contract is initialized, because if it's not initialized, it means we don't have parameters for the limits and the probation period. So we never want to execute a review before we have initialized our contract. So first we verify if we have initialized, and in case we didn't, we just stop the execution right there and throw a message to say, hey, this contract has not been initialized, I cannot move forward. Then we verify if the invoker is the asset contract. So as you remember, we're storing the asset contract, and we want to make sure we are only being called by the asset contract. So this is a pretty standard invocation, and we're just making sure that the asset contract is the guy that is invoking us before we do anything that we need to do next. And something we could improve in the future in here is that we could have maybe different paths. Maybe in case the asset contract is invoking me, I do the normal routine of verifying everything and updating the values with this new transaction. Or in case I'm being invoked by someone else that is not the asset contract, I just verify and let them know if that would be a valid transaction, but I don't carry any changes. I don't treat it as a real transaction that is being executed, and maybe I just treat it as someone checking if this hypothetical transaction would be valid. All right, so moving after we pass through this validation, then we have two main blocks to execute the rules. So how do we do that? The first one is to verify the sender of this transaction, and the second one is to verify separately the receiver of the transaction, because we want to verify from both perspectives. If both the sender is eligible to send this transaction, and if the receiver is eligible to receive this transaction. So we start by the sender, and the first thing we do is to verify if this account is in probation. In case they're not in probation, I don't need to verify anything. I just know that they don't need the rules to be enforced upon them, and they can just transact freely. And the same thing is done to the receiver. In case they are not in probation, we just move forward. But if they are in probation, then we need to verify the limits, and we need to verify how much they can transact. So how do we verify if they're in probation? The way we created this control was by storing the timestamp of the first time this user interacts with the asset. So to do that, anytime the user interacts with the asset, we check, hey, is this the first time? Yes, this is the first time. So I'll store a timestamp of that moment, and from now on, for all the subsequent invocations this user does, for all the times that he interacts with the asset, I just check back how long has been since he started interacting with the asset to see if he's still in probation or not. And in case he has passed probation, then I update his start time to 0, because the only way his start time will be able to be 0 is if I arbitrarily set it as 0, so that I'll know the next time that if I check a probation start time for a given account and it's 0, I know it has been over through probation and it's free to transact. So how do we do this process? First, once we are checking if the user is in probation, we begin by reading from the blockchain what is his probation start time, what is his timestamp from when they started interacting with the asset. So I use this function to read from the blockchain, and here I use a data key that is specific to this address. So I have an account probation start for a given address. So each address will have their own account probation start that makes sure that we're tracking each account individually. So in my read account probation start, I create this data key for the given account that we want to check. And with this data key, I try to read from the blockchain what is the specific timestamp for this account when they started interacting. But it might be the first time, and we might have no value in there. So that's why we do this condition here. We try to read this value. In case there is something stored in there, it means that the user has already interacted with the asset, so we just get this value and return to the other function. But in case we don't find anything, we are not able to read something from the blockchain, it means this is the first time. So then we just return the current timestamp, because it means that right now is the first time they're interacting with the contract. So I'll move back to there, we get this value, and now we just do a bunch of verifications. So as I mentioned the rule before, if the start time is 0, it means that everything was done already, the user has been through their probation time, so they don't need to be in probation, they don't need to have the rules enforced. So we just return false and tell the other function, hey, this guy is not in probation anymore, let them go freely. Now, if it's not 0, this means we need to check how long has passed since the start time. So here we get the current time of the ledger, so what time is it right now, and we verify how long has it been since the user has started interacting with this asset. And here we can have a bunch of different situations. So in case this difference is 0, this means that, yeah, right now is the first time. So if this is the first time, we need to do one extra step. We write a new value for the probation of this user saying, hey, this is the first time this guy is interacting, so let me store that in the blockchain for the next time that I check this value. So here we will write the current time as the time the user started interacting with the asset, and we issue an event that signals to off-chain applications that a user has just started the probation time. This is to help applications that run outside of the blockchain to keep track of what is happening with these contracts and what is going on with the accounts. So after we do these steps, we just return it true to inform the rest of the application that this user is in probation. So we need to enforce the rules. All right, but in case it's not 0, we need to continue to check. So we have two other options. If it's still not over the probation time, which means the user is still in probation, we just signal back, hey, this guy is still in probation, and we don't need to change anything. We just keep the original start time that is stored in there. But if this is not true, the only way a user could get to the end of this function is if he has passed through all the other checks, which means that, hey, this user has gone through probation already, but we hadn't checked that since he passed the probation period. So this means this is the first time that we are checking after he passed the probation period. So we need to update the probation period to reflect that, to store it as 0, so that the next time we don't need to perform all of these checks. We just know that it's 0, and it means the user has gone through probation already. So we write the new value and just return false. All right, so that's the main routine to verify if an account's in probation. Once we know the account's in probation and all the controllers have been updated, we can move on to check the specifics of this transaction for this user. So the first thing for the sender is to check if they have achieved the outflow limit for them with this transaction. To do that, we have other parameters that we use to control. So first, we gotta check what is the outflow limit that we have for this contract. So we read from the blockchain our outflow limit that was initialized with the contract. So let's say 1,000 units. So let's say the limit is 1,000 units. You cannot send more than 1,000 units for a given time. So we store that in a variable, and then we check what was the recent user outflow. And the recent user outflow is how much the user has allocated in this quota already. So if a user can transact 1,000 units every 24 hours, and I perform a transaction for 500 units, it means that I have used 500 units of my quota, and I still have 500 units left. So what we are getting here is how much was used during the last 24 hours. So for that, we are reading what is the current quota that is allocated for these users from the blockchain. So here we read the account activity. The account activity is one type of data that we are storing in the blockchain to register all the activity this account has been doing in the past time. So if we check the data key, we have an account activity that identifier, a data key that uses the address. So each address has its own account activity. And what we store in that is the struct for account activity data. So what is it that we store in there? We store an object that has two vectors. It has an outflow vector and an inflow vector. All right, so what do we have in this? In each one of these vectors, we can have multiple transaction entries, which is this object right here. So a transaction entry is basically a snapshot of every transaction that the user does. So if I am sending money to someone, I'm sending 100 units, my transaction entry would be 100, an amount of 100, the current timestamp of this transaction, so it happened right now. And since I'm sending, this is going to be stored in the outflow vector. So we can have for each 24 hours, we want to be populating this vector with all of the outflowing transactions the user does. And after one of these transactions get past the 24-hour limit, the transaction is dropped from the vector because it's not allocating the quota anymore. So basically, this vector represents my quota. Every entry gets in there once I do a transaction, and it's staying there for the period that I have set as my limit. So let me get back. So what we do here when we read the recent user outflow is that we read the account activity and we select the vector for the direction of the transaction that I'm doing. If I'm sending money, I get just the outflow. If I'm receiving money, I get the inflow. And then I calculate how much is allocated right now for this user. So based on how much I have allocated in right now, in there, I check if by doing the current transaction, am I exceeding this or not? If I'm exceeding it, I'll just throw an error saying, hey, this spender has exceeded the outflow quota, he cannot proceed with the transaction. Otherwise, I'll just move forward and let them do it because the user has not exceeded the outflow quota. Alright, FIFO, but how did we get just the outflow quota from the object of the activity? What we did in here, when we're reading the account quota, is that we have a boolean that tells us if this is an outflow or an inflow. And based on each one of those, we just select which vector we are analyzing, if we're analyzing the outflow vector or the inflow vector, and then we just iterate over this vector to check how much is consumed in that vector. Alright, FIFO, but how do we do this process of selecting just the outflow quota, and how do we know that all the entries in there are still valid? Well, this is done while we're reading the account quota. So what we're doing here is we receive a boolean that tells us if this is an inflow or an outflow transaction, and based on it, we select just the outflow vector or the inflow vector. So once we have the vector, we do a small step before we calculate how much is in that vector. We have to check if any of the transactions in the vector has expired already or not. So for that, we go through this function for get quota consumed for a period. And in this function, we are going to get all the entries in the vector and we are going to verify their timestamps. So we check, hey, based on the limit that we have for each transaction and the current time, which entries in this vector are still valid or are not. So as we are going through the vector, we are getting just the valid ones and adding to a new vector. So basically we are disposing the other ones while we are creating a new vector just with the ones that are still valid. And in this process, we return a vector that contains only the valid transactions. And it is with this vector that we calculate everything and check if we have achieved the limit or not. And in this process, we are also updating which transactions are valid in that vector. All right, let me go back now to the contract. And after we have reviewed the outflow limit and we checked, hey, that's okay, the user can perform the transaction, they can spend this amount, we then record the transaction. And to record the transaction, we are basically adding to the vector the transaction that is being done. So in case this is an outflow, we add to the outflow vector another transaction. If it is an inflow transaction, we add to the inflow and we just update the user activity in the blockchain. All right, so I did all of this verification for the account that is sending the money. And after I checked that the limit was still okay, they had enough quota, and I recorded this transaction on the blockchain, I then throw an event just to tell the applications outside the blockchain that this account has just consumed some more of their quota. This helps the applications track what's going on with the contract. Now we move into the receiver and we do the exact same thing, but checking for the inflow instead of the outflow. So if the receiver has enough inflow limit, if they're not over the quota, we update the transaction in their activity and we also issue an event. But now comes an interesting part. In case the receiver cannot receive anymore, in case this transaction is not valid from the receiver perspective, everything that just happened gets discarded. The transaction fails, and no matter if it was valid for the sender, everything is stopped right away and it doesn't happen. So even if it was valid and we were recording new information for the sender, this is not going to get carried out. We need to make sure that everything works, otherwise the whole transaction will not go through and no parameter will be updated. So after we did the validation for both the sender and the receiver, the transaction just goes through. It goes back to the regulated asset and they perform the normal actions to move the funds and just tell that everything executed correctly and update on the blockchain. So that's how the asset controller verifies and enforces the rules upon the regulated asset contract. So now, getting to the get functions. The get functions are here to help the application provide useful information for their user. So the get quota is the first one, and it's used to verify how much quota this user has used so far. So in this case, it basically receives an address. So this is the account that I'm checking, and we read information from the blockchain using the same functions we used when executing the review in the other steps. And we collect the current allocated inflow and the current allocated outflow. So this will provide me with a value, so how much inflow is currently allocated and how much outflow is currently allocated. I'll bundle those up in a vector and I'll return to the application. So for the application invoking this contract, they'll receive a vector that has two values. all the inflow quota allocated and all the outflow quota allocated. And in case the user has not used one of those, the value would just be 0. So in case they hadn't used any quota so far, they will receive 0 inflow and 0 outflow. For the next one, we can get what is the account probation period. So if I have set a probation period of 1 month, what this do is it loads the information from the contract to check, hey, this contract enforces the probation for a month. Then it reads the probation start period from the user, and in case my probation started, let's say 5 days ago or half a month ago, 15 days ago, it is going to check against the current time to see how much has been since I started interacting with this contract. And in case I still have 15 days ahead of me, this is how much they are going to return. They're going to return a number of how long is still left for my probation period. And in case I have finished my probation period, it's going to return just 0. So the application knows that this user is over probation already. So in case they want to verify before executing a transaction, just to make sure this user can do something without getting any rules enforced that would fail their transaction. Then we have some other functions that are helpful from the user's perspective. And this one is the get quota release time. It's similar to the get quota, but this time, instead of knowing how much quota I have currently allocated for inflow and outflow, this one will structure the activity in the account to return me an array of all of the transactions that I have for inflow and for outflow. And in these arrays, I'm going to have how long each one of these still have to go through. So basically what I do here is that I load these activity vectors, I iterate over them, and I calculate how much has it been since I did the transaction and how long I still have ahead of me before this transaction expires. And then I populate a new array with these values by saying the transaction for 100 units still has 20 minutes to expire. The transaction for 50 units still have 10 minutes before it expires. And then I bundle these up into 2 vectors and I provide to the application. So the application knows in a timeline when I'm going to release some quota and how much I'm going to release from that quota. So that can help the users plan ahead of time when they can do new transactions and what are the amounts that they will be able to transact for. Now going back to the other get functions that we have here, they're pretty standard. They just provide me the parameters that this contract has. So they read what is the probation period that's stored, what is the quota limit that's stored. All of these are parameters that I initialize with the contract, and that's it. That's my asset controller contract. It's pretty simple. It's the first iteration. What we need to do next is to plan ahead on how to improve and optimize these functions and also bring new functionalities to extend the capabilities of this regulated asset. Hope you have liked and see you in the next video.